Hi everyone, it's Miss Spivey. Today we're going to be finishing up Unit 10 and learning about how to make dilutions when in Chem 1. So what you need in order to be successful, you need your Unit 10 book, you need a calculator, you need a periodic table, and you also need to have watched the lecture on how to calculate molarity and you need to know what molarity is. Okay, so open up to page 5 of your Unit 10 book. Top of page 5 of your Unit 10 book says, a dilution involves adding more solvent to the current solution, making the solution weaker than before or more dilute. And then you're given a formula. So my usual example for this is, imagine that it is first period, before you come to school, you go to McDonald's and you buy a sweet tea. Okay, if you are drinking that sweet tea in first period and then you take a drink of it in fourth period, it's not going to taste the same. It's not going to taste the same because all of your ice is melted and your tea is now diluted. Okay, so when we're doing dilution problems, one side of your equation is going to be more concentrated, so that means you're going to have a higher molarity, and the other side of the problem is going to have a lower concentration. So if you're looking at the formula that's either on page 5 in the middle of the page or here on my slide that you can see, M1V1 equals M2V2, the M's the ones and the twos aren't anything to get particularly bent out of shape about. All you need to be able to do is read the word problem that we're given and determine when these, all you need to do is be able to read the problem and determine which side or what values are describing the solution either initially or finally. And it's usually very obvious in terms of like what values go together and are describing that solution at that certain time. Okay, as we go through the problem, we're going to describe, I'll help you think about what is actually happening in a lab, because ultimately the math that we're doing is very easy. It's just algebra 1, but I want you to be able to think about this as a chemist. So what would you do with your math in a lab? Okay, so looking there on page 5, I'm going to work the example problem that's given to you on page 5. And I don't know if you can see that screen now that I think about it. So at the top of page 5, it says, example, how do you prepare a 100 milliliter solution of a 0.4 molar MgSO4 from a stock solution of 2.0 molar MgSO4? So let me kind of give you a rundown of some vocabulary. So when we are diluting a solution, you start with a stock solution, which that's like chemistry slang for a high concentrated solution. You start with a stock solution or something that's highly concentrated and add water. Okay, so how do you prepare a 100 milliliter solution of a 0.4 molar from a stock solution of 2 molar MgSO4? So our equation is MV equals MV. It's very obvious that we're given two values that are relating to a solution at like what we want. Okay, so I have a 0.4 molar solution and I want to make 100 milliliters of it. And we want to know how much of our stock solution, which has a concentration of 2 molar, do we need. So we are solving for the volume of stock solution that we need. Now, when you learned about molarity, we learned that molarity is moles per liters. You have to have units of liters, okay, within the molarity formula. That's not the case when doing dilution problems. You don't have to have liters. You can work dilution problems with milliliters as units as well. So this is our basic algebra here that's going to come out. So need to divide by 2 molar, divide by 2 molar, x equals. So I'm going to multiply the numerator, 0.4 times 100 divided by 2. My molarities cancel, and I'm left with 20 milliliters. Now, this piece here, you could have done in Algebra 1. Okay, that is not difficult math whatsoever. You read a word problem, you interpreted what side of the equation they need to go on, and then we solve for an x, okay? Now, what I want to help you do is think about this like a chemist. Our molarity formula and our dilution formula are formulas that can be used when you're in a lab situation, okay? So, when you make a solution, what's happening is, I want 100 milliliters of a 0.4 molar MgSO4 solution. That was given to me in the problem, okay? So we just did math that shows that 20 milliliters of your solution, so 100 milliliters of our solution, 20 milliliters is going to come from our 2.0 molar stock. So that's our concentrated solution that we're going to be adding water to. How much water do we need to add? The answer is 80 milliliters of H2O. So I would have 80, I would take my 20 milliliters of MgSO4 stock solution, and I would add 80 milliliters of water to it. So I'm going from concentrated 2 molar to weak, it'll be 0.4 molar. So you can use a test tube, you can use a volumetric flask. Typically we would use a volumetric flask, which kind of looks like this, has a longer neck, and then it has one line on it, okay? So let's work another example problem. Let's go to, you don't have any more there in your notes, so let's go to page number 10 in your unit book, page number 10. All right, let's look at number 1. So I'm on page 10 of your unit 10 book, and I'm going to work number 1. Number 1, if I dilute 250 milliliters of a 0.1 molar lithium acetate solution to a volume of 750 milliliters, what will the concentration be? So what I want you to do is pause the video, set up the problem, find the two values that go together on one side of the equation, figure out what your x is going to be. So pause the video and try it on your own. All right, so hopefully you determined that you have 250 milliliters grouped with a 0.1 molar solution. And we want to know what the new concentration is going to be, given that we have 750 milliliters of it. So I divide by 750 milliliters to get my x by itself. X equals, so multiply what's on the top, so 250 times 0.1 divided by 750, and that gives you 0.033 with sig figs molar. So let's again talk about what happened. Initially I had 0.1 molar solution and I had 250 milliliters of it, but then I increased the volume to 750 milliliters. So that means that I added 500 milliliters of water to my solution. And when I did that, my concentration went from being bigger, sorry about that. So this is a more concentrated or a bigger concentration than 0.033 molar is, okay? So the difference between the volumes is just the fact that we added 500 milliliters of water. All right, let's do one more. If you'll skip down to number 3 on page 10. Number 3, page 10. If I leave 750 milliliters of a 0.50 molar sodium chloride solution uncovered on a windowsill and 150 milliliters evaporates, what will the new concentration be? So pause the video, set up your problem. Try it on your own. Hopefully after pausing, you have your problem set up like so. 750 milliliters multiplied by 0.50 molar equals, we're solving for a new concentration, but 150 is not the important value. It's not the new volume. Okay, watch what happens. It says that we had a solution sitting on a windowsill and 150 milliliters of the solvent evaporates. So that's essentially, we have a solution, it evaporates. So it was 750 milliliters. It lost 150 milliliters out into the air when the solvent evaporated. And so that means 750 minus 150 gives us a 600 milliliters that's still left in this container with solute in it. So then I divide by 600. So X equals, so 750 times 0.5 divided by 600. So that gives us 0.625 molar. All right, so this time I had a solution with a 0.50 molar concentration. I had 750 milliliters of it. I lost 150 milliliters due to evaporation, and I'm left with 600 milliliters. So my solution has a higher concentration. Sorry, I'll make this 0.63 with sig figs. My solution has a higher concentration now because I lost my solvent, okay? So remember, we learned that a solute plus a solvent equals a solution. So if I am diluting my solution, I am increasing my solvent, and so that means that I have a lower concentration of solute. Okay, pay close attention to vocabulary words, but ultimately, if you can solve an Algebra 1 type math problem, then you can solve using the dilution formula. Thank you for watching. If you need more help, finish page 10 and have a Chem Squad teacher check it. And there are also going to be more dilution problems towards the back of your book when you do your study guide. So that's going to be page 17, study guide. There's a dilutions worksheet. Okay? So again, ask for help if you need it. Thank you for coming to the Chem Squad website.